Welcome, everyone, to another calming episode of Science to Sleep By, where the wonders of the universe help ease your mind and guide you into rest. Tonight, we're taking a peaceful journey through the cosmic currents that quietly carry our planet through space. Even as you sit still or settle into bed, Earth is moving, spinning, orbiting, drifting, and gliding through the galaxy with a grace so smooth. We never feel a thing. In this episode, we explore that hidden motion, a motion so grand and so gentle that it reminds us how small stresses of daily life are only tiny ripples on a vast cosmic ocean. So take a slow breath, let the day fall away, and let's unwind with the quiet truth of how Earth really moves through the galaxy. There's a strange comfort in the feeling of stillness. When you sit on your couch after a long day, or when you lie down at night and sink into the quiet of your bedroom, everything around you feels stable and moving and familiar. The floor doesn't tremble, the furniture doesn't slide around, and the walls hold steady like they've been waiting for you to rest. Your senses report a world that seems perfectly still, but the truth beneath that feeling is something far more remarkable. Earth is never, at any moment, truly still. It's not simply drifting through space. It's performing a complex ballet of motions layered on top of one another, each one so stable, so smooth, and so ancient that you never feel a single moment of it. This illusion of stillness is one of the greatest natural comforts we experience and understanding. It reveals a deeper sense of peace in the universe. Imagine for a moment that you're sitting quietly in your room. Your body feels grounded. Your breath is slow. There's no movement that you can detect, not from the room, not from the air, not from the planet beneath you. But at that exact moment, the ground beneath you is rotating at hundreds of miles an hour. The entire planet is spinning like a smooth, massive sphere, turning gently on its axis. That means everything you see as motionless is actually moving in a wide circle, completing an enormous rotation every 24 hours. Yet because this rotation is consistent, steady, unchanging, and has been that way for billions of years, you don't feel it. You were born into this motion. Every single person who has ever lived, every plant, every tree, every mountain, every ocean wave, has always been part of this silent spin, and so your brain treats it as stillness. But the illusion goes even deeper. Earth isn't just rotating, it's also orbiting the sun at tremendous speed. As you sit in the apparent calm of your room, you're traveling through space at roughly 67,000 miles per hour along Earth's orbit. That means that every minute you're covering over 1,000 miles. Yet again, you don't feel anything. There are no sudden accelerations, no sharp corners, no shaking. Earth's orbit is smooth, balanced, and gravitationally guided in such a way that you are carried effortlessly along with the planet. Your inner sense of balance doesn't detect any change, because the motion is perfectly constant. Human bodies are sensitive to changes in speed, not steady movement. It's why you can sit on a smooth train and feel as if you're not moving at all until the train slows down or speeds up. Earth's journey around the sun is like the smoothest ride imaginable, stretching across millions of miles without a single bump. Yet even this enormous speed, tens of thousands of miles per hour, is only one small layer of Earth's movement. The sun itself is also moving, racing around the center of the Milky Way galaxy, and it's taking Earth along with it. So while you sit there in your quiet room, you're not only spinning on Earth and orbiting the sun, but you're also sweeping through the galaxy at over 500,000 miles per hour. You are moving along a galactic path so vast that it will take the sun more than 200 million years to complete just one circuit. Every creature that has ever existed has participated in this grand journey without ever sensing it. This galactic motion has been ongoing long before humans existed, before dinosaurs roamed the Earth, before the first single-celled organisms floated through ancient oceans. It's a motion that defines our position in the galaxy, yet it feels indistinguishable from perfect stillness. Then there is the subtle drift of the Milky Way itself, sliding through the universe, pulled by gravitational structures so large we can only study them indirectly. This motion adds yet another layer. It means that as you sit still, you are drifting through cosmic space on a journey that spans billions of years. You are being carried through the cosmic web, through regions shaped by dark matter, through areas where galaxies cluster together in massive, slow-moving formations. This motion is incredibly slow compared to the speed of light, yet unimaginably fast compared to anything we experience on Earth. And still, your senses perceive none of it. This illusion of calm is created by the constancy of these motions. Earth has been moving in these ways for billions of years, and every living organism has evolved in an environment where motion is ever present, but never felt. Our bodies, minds, and senses are calibrated for life on this planet, accepting these cosmic motions as a baseline. We intuitively perceive only changes in acceleration, tiny shifts, vibrations, bumps, or jolts. But cosmic motion is so steady, so smooth, so unwavering, that it becomes indistinguishable from stillness. What makes this more fascinating is the contrast between what we feel and what is actually happening. If you were watching Earth from far away, maybe from a distant star or from a point above the galaxy, you would never describe what you see as still. You'd see Earth spinning, orbiting, drifting, and moving in spirals and arcs that intertwine with the motion of the sun. You'd see a dynamic system where every object is in constant motion, influenced by the gravity of billions of stars. But here on the surface, protected by the atmosphere and grounded by gravity, that entire cosmic choreography feels as calm as a quiet night. This is the heart of the illusion of stillness. The universe is not a place of rest. It is a place of continuous motion. Yet that very motion creates a deep and comforting stability. The steadiness of Earth's movement is what allows life to thrive. It gives us predictable days and nights, seasons, climates, and cycles. The planet behaves like a cosmic cradle, carrying us through space with such gentleness that we can sleep soundly, walk freely, build homes, and dream about the stars without ever feeling the tremendous speeds that keep us in orbit. When we talk about the movement of Earth through the cosmos, one of the most fundamental forms of motion is the rotation of our planet. It's the very first layer in the stack of motions that carry us through the universe, and it's the motion that shapes some of the most familiar rhythms of our daily lives. Yet, even though this rotation is always happening, and even though it affects every second of our existence, it remains completely invisible and imperceptible to us. Earth's spin is smooth, continuous, ancient, and endlessly reliable. It's so perfectly consistent that it forms the backbone of timekeeping itself, and so gentle that it becomes another part of the grand illusion of stillness. We live inside every day. Imagine standing outside on a calm night, feeling the air settle around you, and observing the quiet glow of distant stars. The ground beneath your feet feels firm and unmoving. Yet at that exact moment, you are being carried around the planet's axis at incredible speed. At the equator, Earth is rotating at nearly 1,000 miles per hour. That's faster than the top speed of a jet airline, faster than the sound barrier, faster than any human-made ground vehicle has ever traveled. And yet, you feel none of it. This is because everything around you, the air, the ground, the oceans, the buildings, and your own body is moving with the planet. There is no friction between you and the motion. It is perfectly smooth, perfectly steady, perfectly constant. This seamless coordination is what makes the rotation invisible. What's even more intriguing is that Earth's rotation isn't the same everywhere. At the equator, the spin speed is at its highest because the circumference of Earth is largest there. As you move toward the poles, the circumference decreases, and the rotation speed decreases with it. At the North and South poles, in fact, you would essentially be turning in place, rotating very slowly in a tight circle over the span of a day. Yet whether you live near the poles, the equator, or somewhere in between, the rotation is so uniform that your senses cannot detect any difference. The only evidence you ever perceive is the cycle of day and night, the rising and setting of the sun, which is not the sun moving across the sky, but Earth turning beneath the light. This rotation is not random. It has a long and dramatic origin story tracing back to the birth of the solar system itself. Over 4.5 billion years ago, when the sun was forming from a collapsing cloud of gas and dust, the leftover material began to rotate. Pieces of rock, ice, and metal swirled around the newborn sun, colliding and merging into larger bodies. One of those bodies eventually became Earth. Because the material in the early solar system already possessed angular momentum, the newly forming planets inherited that rotation. Earth's spin is essentially a remnant of the solar system's birth, and it has been slowing down only slightly over billions of years. As tidal forces from the moon gradually stretch and tug at our planet, even though the rotation is invisible to our senses, its effects are everywhere. It shapes the pattern of sunrise and sunset, marking the boundaries of a day. It generates the Coriolis effect, influencing wind patterns, storm rotations, and the flow of ocean currents. It plays a role in the shape of Earth itself. The planet is not a perfect sphere, but an oblate spheroid, meaning it is slightly flattened at the poles and bulging at the equator. This bulge exists because the rotation causes the equatorial regions to experience a stronger outward centrifugal effect. Over billions of years, Earth has settled into this balanced, slightly rounded shape, a quiet testament to the power of its constant spin. Even though Earth's rotation is incredibly fast, it is also remarkably stable. This stability allows us to build structures, travel, work, sleep, and live without any sensation of movement. The rotational speed doesn't fluctuate rapidly. There are no sudden accelerations or decelerations. The spin is held in check by the planet's mass, its shape, and the conservation of angular momentum. This steadiness creates a comforting sense of reliability in our world. We know that after every night, daylight will return. After every sunset, darkness will follow. These cycles have guided humanity for thousands of years. They have shaped agricultural seasons, religious traditions, biological rhythms, and natural behaviors across the globe. One of the most fascinating aspects of Earth's rotation is how much it contributes to our internal sense of order. Our circadian rhythms, the biological clocks that regulate sleep and wakefulness, are synchronized with Earth's day-night cycle. Even before the invention of clocks, humans oriented their lives around the rising and setting of the sun, understanding instinctively that Earth's rotation was a dependable pattern. If Earth suddenly stopped spinning, a purely hypothetical scenario, the consequences would be catastrophic. Winds would roar across the planet at unimaginable speeds, oceans would surge violently, and the cycle of day and night would halt. But that scenario remains an impossibility for our lifetimes. Earth's rotation has lasted for billions of years, and will continue for billions more, slowing only by fractions of a millisecond each century. The rotation also connects us to the rest of the cosmos in a subtle way. The motion of the stars across the sky, the arc of the moon, and the shifting of constellations all appear as patterns because Earth is turning. When you look up at the night sky and see stars drifting slowly from east to west, you are witnessing the effect of your own motion. The stars are not circling around you. You are spinning beneath them. This perspective can feel humbling, even soothing, because it places you within a long and ancient dance of celestial mechanics. You are not simply an observer of the universe, you are part of its continuous, elegant motion. Earth's rotation represents the first and most immediate layer of how our planet moves through the cosmos. It is the foundation upon which all other motions are built. From the daily cycle of light and dark, to the deeper patterns woven into the laws of physics, the rotation defines the rhythm of life on Earth. It carries everything on the surface with perfect precision, creating an environment where we can live without ever sensing the incredible speed at which we move. When you think about Earth moving around the sun, it's easy to imagine a simple circular path, a clean loop drawn around a glowing center. But Earth's orbit is far more intricate, more dynamic, and more beautiful than a perfect circle. It is a journey shaped by gravity, momentum, ancient cosmic collisions, and the quiet pull of celestial mechanics that guide our planet with unwavering consistency. This orbit, traveling at nearly 67,000 miles per hour, is one of the most essential motions that define our existence. It determines our seasons, influences our climate, and keeps us anchored to the sun's life-giving warmth. And yet, just like Earth's rotation, we never feel a moment of this enormous speed, because everything around us moves in perfect unison. To understand Earth's orbit, Picture our planet suspended in an enormous gravitational relationship with the Sun. Gravity is not simply a force that pulls things downward. In the grand scale of the cosmos, gravity is the architect of motion. It shapes paths, curves, space, and choreographs the sweeping arcs of planets and stars. Earth's orbit is the result of two forces working together, the Sun's gravity pulling inward and Earth's forward momentum pulling outward. These two motions balance in such a precise way that Earth falls around the Sun instead of falling into it. It's a delicate cosmic dance, where motion and attraction combine to create a stable, repeating path. This path, however, is not a perfect circle. Earth travels in an ellipse, an oval-shaped orbit that stretches slightly as the planet moves from its closest point to its farthest point from the Sun. At its closest approach, called perihelion, Earth is about 91 million miles from the Sun. At its farthest point, called aphelion, it's about 94 million miles away. This difference may seem large, but spread across the enormous scale of space, it creates a smooth, gentle variation in our distance that contributes to seasonal patterns, but does not dominate them. Many people assume that the seasons are caused by Earth being nearer or farther from the Sun, but the truth is more subtle. The tilt of Earth's axis, not its elliptical orbit, is the primary driver of seasonal change. Yet the slight variation in distance adds a fine layer of complexity that shapes the planet's climate over long periods. The speed at which Earth travels along this elliptical orbit is astounding. At 67,000 miles per hour, Earth covers more than 1 million miles every day. And still, there is no sensation of movement. The reason is the same as with rotation. Everything on Earth, including the atmosphere, the oceans, the continents, and our own bodies, moves with the planet. There is no shift in acceleration, no vibration, no change in speed that our senses can detect. We are passengers on a vessel whose motion is perfectly smooth and perfectly consistent. This creates a deep sense of stability within a universe that is constantly in motion. Despite its steadiness, Earth's orbit is not static. It evolves slowly over long stretches of time due to gravitational interactions with other planets, especially Jupiter and Saturn, as well as subtle changes in Earth's axial tilt and wobble. Over tens of thousands of years, these shifts influence the shape of the orbit, the severity of seasons, and even the timing of ice ages. These variations, known as Milankovitch cycles, shape the deep climate patterns of Earth across geological eras. While these changes are too gradual to feel within a human lifetime, they reveal that even stable cosmic systems are still dynamic on larger timescales. Another fascinating aspect of Earth's orbit is the balance of light and darkness it creates. The orbit ensures that every region on Earth experiences the Sun's energy in a predictable, repeating pattern. This regularity is essential for life. Plants depend on annual cycles to grow and reproduce. Animals migrate in response to seasonal changes. Human societies have designed calendars, holidays, agricultural systems, and cultural rhythms based on the movement of Earth around the Sun. Entire civilizations have risen and fallen while Earth continued its steady journey on the same elliptical path. The orbit also creates an extraordinary sense of perspective. As Earth travels around the Sun, the night sky changes with the seasons. The constellations we see in summer are different from those in winter because Earth is looking outward into different regions of the galaxy along its orbital path. This shifting view is a reminder that our planet is constantly moving, constantly changing the angle from which we observe the universe. The sky becomes a kind of celestial calendar, with star patterns acting as markers on our cosmic route around the Sun. Even though the orbit is stable, maintaining it requires an extraordinary balance of forces. If Earth were moving much slower, the Sun's gravity would pull it inward, and the planet could spiral toward the Sun. If Earth were moving much faster, it would escape the Sun's grip and drift into deep space. But the planet's speed is exactly what it needs to remain in a stable orbit. A speed determined by the mass of the Sun, the distance between the two bodies, and the initial conditions that shaped the early solar system. These conditions have not changed significantly over billions of years, allowing Earth to maintain a reliable path that sustains life. Earth's orbit also connects us to the broader cosmic environment. As our planet moves around the Sun, it encounters streams of cosmic dust and meteor particles. These interactions produce meteor showers, gentle reminders that Earth is traveling through a dynamic region of space filled with debris left behind by comets and asteroids. Most of these particles are tiny, burning up harmlessly in the atmosphere, creating streaks of light that mark our planet's passage through these ancient trails. What makes Earth's orbit particularly soothing to think about is the sheer scale of its predictability. Every year, Earth completes a full loop around the Sun, returning to nearly the same position in its path. This cycle repeats with such precision that it defines the length of a year. The predictability is a gift, a kind of cosmic reassurance. No matter what happens in our daily lives, no matter how chaotic or uncertain the world may feel, Earth continues its path with quiet reliability. It travels through space with such smoothness that we can build homes, raise families, create traditions, and fall asleep each night without ever fearing a sudden change in the planet's motion. As Earth moves along its orbit, it carries us through a perfectly balanced system shaped by gravity and momentum, a system that allows light to warm the planet, seasons to change gently, and life to flourish in a stable environment. The orbit is a silent, constant companion, guiding us through the vastness of space, without a sound, without a tremor, without a single moment of disruption to the fragile world we call home. When we talk about Earth's movement, it's easy to focus on the rotation of our planet or its orbit around the Sun, because these are the motions most familiar to us. But beyond these, there is another motion far larger, far more majestic, and far more mysterious. It is the motion of the entire solar system as it travels around the center of the Milky Way galaxy. This motion carries not just Earth, not just the Sun, but all 8 planets, countless asteroids, comets, dwarf planets, moons, and clouds of interstellar dust. It is a motion that spans hundreds of millions of years, a cosmic journey so vast that humanity has existed for only a fraction of a single orbit. And yet, just like Earth's other motions, we feel none of it. It's a silent flow through the galaxy, smooth and unbroken, shaping our place in the universe in ways we rarely consider. Imagine the Sun as a traveler moving across an enormous, star-filled landscape. It is not stationary at the center of our solar system, the way many simple diagrams might suggest. Instead, the Sun is a dynamic, moving star orbiting the galactic core, just like all the other stars in the Milky Way. Earth's orbit around the Sun, which seems so large and so dominant from our perspective, is only a small looping spiral layered on top of this much larger motion. As the Sun moves forward through space, Earth moves around the Sun in a complex helical pattern like a tiny bead circling a thread that stretches across the galaxy. This means that our planet never returns to the exact same place in space, not even after billions of years. The speed of this galactic orbit is staggering over 500,000 miles per hour. At this speed, Earth, the Sun, and every object gravitationally bound to our star are racing through the galaxy at a pace that defies human intuition. Even so, this motion remains invisible and undetectable in everyday life. There is no wind from the galaxy sweeping past us, no sensation of acceleration, no sense of direction. This is because everything in the solar system moves together in perfect harmony. The Sun's gravity ties all planets into a coherent family, and that family moves as one through the Milky Way's gravitational landscape. There is no internal friction, no jarring movement, no sudden shifts. It's a steady drift across hundreds of billions of miles. The Sun's orbit around the Milky Way takes about 225 to 250 million years to complete one lap. Astronomers sometimes call this a galactic year. To put this into perspective, consider that the last time the solar system was in this part of the galaxy, dinosaurs had not yet appeared on Earth. When the Sun completes one full orbit, the surface of Earth will look entirely different than it does today. Continents will have shifted, species will have evolved or vanished, Civilizations will have risen and fallen. A single galactic year contains more than 1,000 lifetimes of human history combined. And yet, throughout all that time, the solar system continues gliding along its orbit with the same quiet grace. This orbit is shaped by the immense mass at the center of the Milky Way, including a supermassive black hole known as Sagittarius A. But the black hole is only a small part of the story. Most of the gravitational pull comes from the stars, gas clouds, and dark matter that make up the rest of the galaxy. Dark matter, in particular, is thought to contribute the majority of the mass in the Milky Way, forming a vast, invisible halo that extends far beyond the visible spiral arms. It is this combination of ordinary matter and dark matter that holds the solar system in place, guiding it along a curved path through the galactic disk. As the Sun orbits the galaxy, it doesn't travel in a flat plane. Instead, it gently bobs up and down through the Milky Way's disk, like a ship riding a slow cosmic wave. Every few tens of millions of years, the solar system moves slightly above or below the galactic plane. These vertical oscillations may influence long-term patterns in Earth's environment, though the exact effects are still a subject of scientific study. Some theories suggest that the solar system's path through regions of greater or lesser density in the galaxy could affect the influx of cosmic rays or the distribution of interstellar dust. While these influences remain subtle on a human timescale, they remind us that Earth's environment is connected to the broader galaxy in ways we are still learning to understand. Traveling around the galaxy also means encountering different regions of interstellar space. Sometimes the solar system drifts through areas rich with gas and dust, and other times through clearer, emptier regions. Millions of years ago, our solar system may have passed through dense interstellar clouds that affected Earth's climate by altering the intensity of the sun's light reaching the planet. Today, the solar system sits inside a region known as the local bubble, a cavity of low-density gas carved by ancient supernova. This bubble provides a relatively calm and stable neighborhood for our solar journey, protecting Earth from the harsher environments that exist elsewhere in the galaxy. Perhaps one of the most beautiful aspects of this galactic motion is how it shapes the night sky. The constellations we see change slowly over tens of thousands of years, not just because Earth's axial tilt shifts, but because the Sun is moving through the galaxy. As we drift through different regions of the Milky Way, the background of stars subtly shifts. Future humans, millions of years from now, will look up at a night sky filled with constellations completely unfamiliar to us. The stars themselves change position over time, but the movement of the solar system through the galaxy adds another layer to this gradual transformation. Even though we never feel this motion, it plays a profound role in shaping our understanding of the universe. It reminds us that Earth is not the center of anything, not a fixed point in space, but a moving participant in a vast and elegant system. It reinforces the idea that we are part of a cosmic journey far larger than ourselves, a journey shared by every star, planet, and living being in the galaxy. It transforms the concept of home from something static to something dynamic, something moving, something alive. As the solar system continues its orbit, it carries Earth through a galaxy filled with beauty and wonder, stellar nurseries where new stars are born, supernova remnants glowing with energy, ancient star clusters sending faint light across unimaginable distances. We travel among billions of stars, each with worlds of their own, each following their own path around the galactic center. And through it all, the Sun guides us, pulling Earth along with a steady warmth, a constant presence, a quiet stability that allows life to flourish even as we drift through the depths of the Milky Way. When we imagine the solar system moving around the Milky Way, it's easy to picture a neat circular path, a smooth orbit, and a stable position within a grand spiral of stars. But the reality is far more intricate, far more fluid, and far more poetic. The solar system doesn't simply orbit the galaxy like a planet orbits a star. Instead, it drifts, weaves, oscillates, and flows through an ever-changing galactic environment. This motion, this subtle, almost musical drift, is one of the most delicate, and least understood layers of Earth's cosmic journey. And although it is completely silent and utterly unfelt, it gives us profound insight into where we truly exist within the vastness of the Milky Way. To understand this drift, imagine the Milky Way not as a flat disk, but as a vast, dynamic structure filled with stars, gas clouds, dark matter, and swirling gravitational interactions. The sun does not move along a single, perfectly defined trail. Instead, it follows a path shaped by countless influences, some gentle, some powerful, some ancient, and some continuously evolving. It is like traveling through an ocean with invisible currents, each one subtly adjusting the course of your ship. Over time, these shifts create a delicate pattern of motion, one that carries the solar system through regions of varying density, temperature, composition, and cosmic history. One of the most important elements of this drift is the solar system's slow, wave-like motion through the galactic disk. The Milky Way's disk has thickness, structure, and a vertical profile, not just a two-dimensional plane. As the sun orbits the galactic center, it also moves up and down relative to the midplane of the galaxy. This vertical oscillation takes millions of years to complete. At times, the solar system sits slightly above the galactic plane. At other times, it drifts below it. During each oscillation, the environment around the solar system subtly changes. The density of stars shifts. The concentration of interstellar dust varies. The influence of passing gas clouds becomes stronger or weaker. These changes are extremely gradual, far too slow for humans to notice. But over millions of years, they shape the cosmic environment through which Earth travels. Another component of the galactic drift involves the solar system's movement relative to nearby stars. Our sun is not locked in place among its neighbors. Stars in the Milky Way orbit at slightly different speeds, influenced by their mass, distance from the galactic center, and the gravitational tug of surrounding matter. As a result, the sun gently weaves through local star populations, sometimes moving closer to one group of stars, sometimes drifting away toward another. Over tens of thousands of years, the positions of nearby stars shift in a slow celestial dance. To ancient humans, the stars appeared fixed and eternal, but in truth, they are all moving, all dancing across the galaxy with us. This drift also means that the solar system is slowly traveling toward a point in the sky known as the solar apex, located near the bright star Vega in the constellation Lyra. This motion is incredibly subtle, about 12 miles per second relative to nearby stars, but over long periods of time, it changes the orientation of the night sky. It means that the sky of the far future will be filled with constellations unfamiliar to us, shaped by our movement toward new stellar neighborhoods. Among the most mysterious influences on this drift is dark matter. Although invisible and undetectable by conventional means, dark matter forms an enormous halo around the Milky Way, extending far beyond the visible galaxy. This halo contributes the majority of the galaxy's mass, and its gravitational pull guides the paths of stars, including the sun. We do not feel it, we do not see it, and yet it shapes the very course of our cosmic journey. It determines how the sun sways through the galaxy. It influences our orbital velocity. It defines our position within the gravitational landscape of the Milky Way. In many ways, the drift of the solar system is a conversation between the sun and the galaxy's unseen mass, a gravitational whisper exchanged across millions of years. The galactic drift also affects the cosmic environment Earth passes through. As the solar system travels, it encounters interstellar clouds, vast regions of dust and gas left behind by ancient stars. These clouds can vary dramatically in density. When the solar system passes through a denser region, it can subtly distort the heliosphere, the protective bubble formed by the sun's solar wind. A compressed heliosphere may allow more cosmic rays to reach Earth, influencing atmospheric chemistry or interacting with cloud formation. These effects are far too tiny to notice in everyday life, but they remind us that Earth's environment is not entirely isolated. It is influenced by the galaxy's architecture, by the cosmic weather of interstellar space, and by the slow drift of the solar system through regions shaped by ancient explosions, dying stars, and the remnants of galactic evolution. Even the night sky reveals the story of this drift. As Earth drifts through the galaxy, the alignment of the stars changes slowly over time. In tens of millions of years, familiar constellations like Orion and Ursa Major will no longer exist in their current form. Stars will shift, patterns will dissolve, and new patterns will slowly emerge. The night sky is a cosmic map, always changing, always evolving, always reflecting our movement through the Milky Way. The stars we see today are a snapshot of our current position in the galaxy, a position that humanity has occupied for only a fleeting moment in cosmic time. This drift also reminds us that we are part of a galaxy filled with structure. Spiral arms, dense clusters, thin regions, thick regions, and even regions filled with the energetic remains of supernova all shape the environment around us. The solar system is currently located in a small interstellar neighborhood known as the local interstellar cloud, which itself is moving through a larger cavity called the local bubble. These structures were carved by ancient stellar explosions, long before the sun existed. They are the fingerprints of the galaxy's past, and the solar system drifts through them like a traveler wandering through landscapes shaped by forgotten histories. Perhaps the most poetic aspect of this galactic drift is the way it reframes our sense of home. We often imagine Earth as stationary, the sun as central, and the galaxy as a distant and changing background. But the drift reveals that nothing is fixed. Home is not a single point in space. It is a path. It is a journey. It is a movement through an ever-changing cosmic environment, carried by forces vast and ancient, guided by gravity, dust, stars, and the invisible framework of dark matter. Earth is not just orbiting the sun. It is drifting across a galaxy that is itself moving through the universe. And in this drift, in this gentle passage through cosmic space, we find our true place, not fixed, not still, but part of an elegant, continuous journey through the Milky Way. When we imagine our place in the universe, we often think of Earth moving around the sun, or the sun guiding the planets around the Milky Way. But the story of motion does not end with our solar system's orbit. There is a deeper layer, one that stretches across unimaginable distances and unfolds across billions of years. This is the motion of the Milky Way itself, a giant spiral galaxy drifting, falling, and flowing through the cosmic landscape. And as the Milky Way moves, everything inside it moves as well. Every star, every planet, every dust cloud, and every living thing on Earth is part of that motion. It is a quiet journey, one we do not see or feel, but one that shapes our place in the cosmos. To understand how the Milky Way moves, imagine a city floating on a vast, invisible ocean. The galaxy is like that city, drifting through a sea of cosmic structures, pulled and nudged by gravitational currents we can barely measure. Our galaxy is not anchored to anything. There is no fixed point in space where the Milky Way rests or spins. Instead, it is carried along by the gravitational pull of massive clusters, superclusters, and even larger arrangements of galaxies that form the cosmic web. The Milky Way moves at astonishing speeds, around 1.3 million miles per hour, toward a region of space called the Great Attractor, a mysterious gravitational anomaly buried within the Laniakea supercluster. Even though the name sounds dramatic, the motion is not chaotic. It is slow, steady, and incredibly smooth, stretching across millions of years. The Great Attractor is not a single object, but rather a gravitational focal point created by the combined mass of millions of galaxies. Our galaxy, along with many others in our region of the universe, is gently falling toward this region. It is not a fall we will ever feel. The pull is so subtle across such vast distances that every part of the Milky Way moves together, perfectly synchronized, as if the galaxy were a single, unified body. And because everything inside the galaxy is bound by gravity, we move right along with it, unaware that we are part of a grand cosmic migration. But the Milky Way's motion is not driven only by this attraction. The galaxy also drifts through space as part of the local group, a small collection of galaxies that includes Andromeda, Triangulum, and dozens of smaller dwarf galaxies. The local group itself moves through the larger Laniakea supercluster, which spans 520 million light-years. Imagine the Milky Way as a small boat caught in the current of a giant, slow-moving river. The river stretches so far that we can only map small portions of it, and the current flows so gently that the entire boat moves uniformly. We move with the local group, not because of a single force, but because gravity creates enormous pathways across space. And galaxies follow those pathways like leaves drifting on a breeze. Our galaxy also moves because of dark matter, the invisible substance that makes up most of the Milky Way's mass. Dark matter creates a giant halo round the galaxy, shaping its motion and acting like a gravitational cushion that holds stars in place. Without dark matter, the stars in the Milky Way would spin too fast and drift away. But with it, the galaxy remains stable as it travels through space. We do not see dark matter, but we feel its influence. It forms the gravitational skeleton that guides the galaxy's motion and connects it to other galaxies across the cosmic web. Just as the bones of your body support you without drawing attention to themselves, dark matter supports the galaxy in silence. Another layer of motion comes from the expansion of the universe itself. Space is stretching in every direction, causing galaxies far from us to move away at increasing speeds. However, galaxies within gravitationally bound structures like our local group or the Laniakea supercluster do not drift apart. Their internal gravity is strong enough to hold them together despite the expansion. This means the Milky Way is caught between two forces: the inward pull of gravity from nearby clusters and the outward push of cosmic expansion. These forces balance in a way that creates a gentle, continuous drift across billions of years. We are not moving in a straight line or toward a single destination. Instead, we are flowing through space along a path shaped by gravity, mass, and time. Even the Andromeda galaxy plays a role in the Milky Way's motion. Andromeda and the Milky Way are on a slow-motion collision course, expected to meet in about 4.5 billion years. The two galaxies move toward each other at around 250,000 miles per hour. But again, this motion is so smooth and so slow on human timescales that it does not disturb our daily lives. The galaxies are far too large, and the stars far too spread out, for any dramatic effects to occur anytime soon. Instead, this motion adds another layer of calm inevitability to the galaxy's journey. We are part of a cosmic choreography that takes place over eons altogether. The Milky Way's motion is a quiet reminder that everything in the universe is in motion. There is no stillness in the cosmos, only layers of movement that unfold across distances too vast to fully comprehend. Yet even though we travel through space at unimaginable speeds, we feel none of it. Gravity holds everything together, keeping Earth stable and life calm as the galaxy glides through the universe. The motion of the Milky Way is gentle, coordinated, and perfectly suited for life to unfold on a small blue planet drifting silently through the stars. When we ask how fast Earth is moving, the answer isn't simple, because Earth is never moving in just one way. Our planet travels through the universe on several levels at once, with each layer of motion stacked on top of another like a series of gentle, invisible currents. We are not just rotating, just orbiting, just circling the galaxy. We are drifting, falling, gliding, and flowing through cosmic space in a complex pattern of motion that seems overwhelming when described, but feels perfectly calm from where we sit. This layered motion defines our cosmic existence, and yet, we live our entire lives without feeling even a fraction of its first layer of motion is Earth's rotation. As Earth spins on its axis, every point on the surface traces a circular path through space. At the equator, this path moves at around 1,000 miles per hour, though the speed slows as you move toward the poles. This spinning creates day and night, sets the rhythm of our lives, and acts as the foundation of the motion we are most familiar with. But compared to the greater motions of the universe, Earth's rotation is only the beginning. It is the smallest wave in an ocean of cosmic movement. The next layer is Earth's orbit around the Sun, at around 67,000 miles per hour. This motion is much faster than Earth's rotation, though we still do not feel it. The orbit is smooth and stable, held in place by the Sun's gravity. Gravity creates a kind of cosmic tension, a balance between Earth's forward momentum and the Sun's pull inward. This balance ensures that instead of flying off into space or falling into the Sun, Earth moves in a long, gentle loop around our star. The journey takes a full year to complete and lays the foundation for our seasons, the tilt of our planet, adding the variation that shapes the experience of summer and winter. Even though this motion is fast, it feels effortless because the entire Earth moves as one unified body. The third layer of motion comes from the movement of our solar system around the Milky Way. The Sun, along with all its planets, sweeps through the galaxy at around 514,000 miles per hour. This, too, is a journey we never sense, because the solar system moves together within the Sun's gravitational field. We orbit the galactic center roughly every 230 million years, a cycle sometimes referred to as a galactic year. During one galactic year, entire species evolve and vanish, continents drift, oceans rise and fall, and civilizations rise and disappear, all while the Earth quietly follows the Sun on this vast celestial loop. Even this tremendous speed means little when measured across the enormous scale of the galaxy. But it adds another layer to the question of how fast we are truly moving by, and the solar orbit is another layer, the drift of the entire galaxy through space. The Milky Way itself moves at around 1.3 million miles per hour as it falls toward a region known as the Great Attractor. This enormous gravitational region, made up of galaxy clusters and dense structures, exerts a subtle pull across millions of light years. The Milky Way is not alone in this motion. It travels in the company of many other galaxies, each one following a similar path through the cosmic web. This motion adds a fourth layer to our cosmic speed, even though we never experience any sensation of movement. Every star, every planet, every moon, and every life form on Earth is carried together through this flow, as if the galaxy were a single ship drifting across a silent sea. Beyond even this, there is the expansion of the universe. Space itself is stretching, carrying distant galaxies farther away from us. While gravitationally bound structures like the Milky Way and its neighbors remain together, more distant galaxies are carried away by this expansion at speeds that increase with distance. This adds another layer to the motion of Earth. We are not only moving through space. Space itself is shifting beneath our motion. It is like walking on a conveyor belt that itself is moving. We are simultaneously traveling through space and accompanied by the movement of space itself. This cosmic expansion adds another subtle but profound ingredient to the motion of everything in the universe. When all these motions are combined, the total speed becomes almost impossible to comprehend. Earth rotates at 1,000 miles per hour, orbits the Sun at 67,000 miles per hour, follows the Sun around the galaxy at over 500,000 miles per hour, and drifts with the Milky Way at over 1.3 million miles per hour. Add in the effect of cosmic expansion and gravitational flows, and Earth's real motion becomes a layered journey through space at millions of miles per hour. Yet despite this staggering total, we do not feel anything unusual. This is because motion is relative. Everything around us shares these motions. The atmosphere, the oceans, the buildings, the landscape, the ground beneath our feet, and our own bodies move together in perfect synchronization. There are no bumps, no sudden shifts, no jolts. Because the motions are constant and unchanging over human timescales, it is only when we step back and consider the full picture that the scale of our motion becomes clear. We are not anchored in space, not resting on a solid foundation. We are travelers on a planet that is part of a solar system, drifting through a galaxy that is itself flowing through the universe. Every layer of motion blends into the next, creating a smooth and unified journey that has continued for billions of years. And this layered motion reminds us of something quietly profound. Even though nothing in the universe is ever truly still, The forces of gravity and cosmic structure create a sense of stability that allows life to flourish. We move through the cosmos at unimaginable speeds, yet we experience peace and stillness here on Earth, held together by the harmony of all these layers of cosmic motion. When we finally step back and look at all the layers of Earth's motion, from the slow turning of our planet to the vast glide of the Milky Way across the universe, the natural question becomes what this motion truly means for us, not in a scientific sense alone, but in a personal, human way. We live on a world that is never still, a world that rides on invisible currents of gravity and momentum, a world that does not simply sit in space, but flows through it with extraordinary grace. And yet, for all this movement, our lives feel grounded. The ground beneath our feet feels steady, the horizon feels fixed, and our daily routines unfold with a rhythm that seems anchored and dependable. Understanding Earth's true motion can reshape the way we think about stability, safety, and our place in the cosmos. Instead of making our world feel fragile, this knowledge shows us how deeply protected and supported we truly are. Earth moves through the universe with astonishing speed. It rotates, orbits the sun, orbits the center of the galaxy, drifts with the Milky Way, and rides the expansion of the cosmos itself. Every layer of this motion is enormous, yet it all happens in perfect harmony. The reason we never feel these motions is because gravity binds everything together so smoothly. It is not just the gravity of Earth holding us to the ground, but the layered gravity of the sun, the galaxy, and the cosmic structures beyond. These gravitational forces act like the guiding hands of a cosmic ballet, ensuring that every planet, star, and galaxy follows a path shaped by balance and elegance, rather than chaos. We exist in the middle of this motion without disruption, because the universe is far more orderly than it might seem at first glance. This stability is part of what makes life possible. If Earth's orbit were jagged or unpredictable, if the solar system's movement through the galaxy were erratic, or if the Milky Way lurched through space instead of drifting smoothly, life, as we know it, could never thrive. Plants rely on dependable cycles of light and dark. Oceans follow predictable tides. Weather patterns develop from stable seasonal shifts. The existence of ecosystems, climates, and life itself depends on the calm regularity of Earth's motions. Even the galaxy's gentle drift avoids violent gravitational disturbances that could disrupt solar systems or hurl planets into uninhabitable orbits. The universe's scale might be immense, and its speeds might be beyond comprehension, but it is the consistency of these motions that matters most for us. They create a cosmic environment where life has the time and space to evolve, grow, and flourish. There is something deeply comforting about knowing that stability does not come from stillness. It comes from harmony. The Earth is safe, not because it is motionless, but because its motions are steady, ancient, and predictable. Everything in the cosmos is in motion. Even the particles in your body move constantly, shifting and vibrating, held together by forces you never consciously feel. The universe is not defined by rigidity or rest, but by balanced movement. Stability is the result of forces working together over billions of years to create order out of energy and gravity. We are part of that order, living within a structure that has been refined by cosmic time. Understanding this invites us to soften into a sense of peace. Just as Earth moves through the galaxy without strain, we too move through our lives, carried by forces we don't always notice. Stress, pressure, expectations, and responsibilities can make us feel as though we must fight for stability, as though stillness must be achieved by controlling everything around us. But when we look at Earth's example, we see a different truth. The planet's calm, stable experience does not come from resisting motion, but from moving gracefully with the forces around it. Earth follows the curve of space, the pull of gravity, and the paths shaped by the universe. It moves because everything moves, and its stability comes from trusting those motions to unfold naturally. Nothing in the universe forces itself into stillness. Instead, everything finds balance within motion. There is also a humbling beauty in realizing how deeply interconnected we are with the cosmic world. We are not separate from the galaxy's movement or the universe's expansion. Every breath we take, every thought we have, every moment of life on this planet is happening within the flow of cosmic motion. The atoms that make up our bodies were forged in stars that once moved through space, much like our sun does now. The molecules that shape our world were carried across billions of years by the same gravitational currents that guide Earth today. In a very real sense, the universe's motion is part of our biology, our history, and our identity. Understanding Earth's movement is not just a scientific idea. It is an invitation to recognize our connection to the larger cosmic story. This perspective also opens the door to introspection. Just as Earth is always moving, whether we feel it or not, our lives move forward even in moments that seem still. Growth happens quietly. Healing happens in small, unnoticed shifts. Moments of clarity arise after long periods of gradual change. Much like Earth's layered motions, our personal journeys are made up of many currents flowing at once. Some are fast, like decisions or emotions that move quickly. Others are slow, long-term aspirations or internal transformations that unfold over years. Understanding Earth's layered motion helps us see our own experiences more gently. We may not always feel ourselves moving forward, but we are. Life carries us quietly, steadily, and often more smoothly than we realize. The cosmic stability we experience can also inspire gratitude. We live in a universe where the forces of gravity, mass, and momentum combine to create a safe, dependable home for life on a planet that spins and orbits without ever losing its balance. When we see the world this way, even simple moments gain depth. A quiet morning, a cool breeze, a night sky filled with stars, or the soft hum of a familiar routine becomes a reminder that we are part of something far larger than ourselves. Earth's journey through the galaxy is a constant reassurance that the universe supports life, not through stillness, but through the harmony of motion. And as we drift on this small world through cosmic space, we are held by the same gentle forces that have guided Earth for billions of years. The stability we feel is real, even though everything around us is always moving. It is a stability born not from the absence of motion, but from the quiet perfection of motion working in balance with itself. As we reach the end of this quiet journey through Earth's layered motions, we return to a simple but profound truth. Nothing in the universe is ever still, and yet everything moves with a calmness so complete that we live our entire lives in peace. From the gentle rotation of our planet to the sweeping orbit around the sun, from the sun's long spiral around the Milky Way to the galaxy's slow drift through the cosmic web, we are carried through space on currents older and smoother than anything we can imagine. These motions are immense, stretching across billions of miles and billions of years, but they never disturb the rhythm of a single human breath. Through this exploration, we've peeled back the layers of Earth's journey, discovering that our planet is part of a cosmic choreography far greater than our daily experiences reveal. We learned that Earth rotates with quiet consistency, orbits the sun in a stable elliptical path, follows the sun around the galactic center, rises and falls through the Milky Way's disk, drifts with the galaxy toward the great attractor, and rides the expansion of the universe itself. Each of these motions adds depth to our place in the cosmos, shaping a story not of chaos, but of incredible order. The universe, in all its vastness, operates with the harmony that makes life possible on this small, blue world, and through it all, we remain unaware of these magnificent speeds. We never sense the million-mile-per-hour drift of our galaxy, nor the sweeping arc of our solar orbit. We never feel the pull of distant clusters or the expansion of space. Understanding Earth's true motion can shift something inside us. It reminds us that stability does not require stillness, and peace does not demand that everything around us stop moving. Instead, peace is found in harmony, in balance, in trusting the natural motion of things. Just as Earth moves through the galaxy effortlessly, carried by forces that have held it for billions of years, we too can allow ourselves to move through our days without needing to control every moment. We can breathe more softly, think more gently, and trust that not every part of life needs to be felt to be real. Sometimes the greatest motions happen quietly, and the most meaningful growth occurs in silenzia. As you take this final moment to settle, let your mind rest in the cosmic perspective we've explored tonight. You are on a world that drifts through the universe with elegance. You are part of a galaxy that glides through cosmic space with grace. And you are shaped from the very same atoms forged in ancient stars that once traveled these same paths. You are connected to the universe, not in metaphor, but in matter, in motion, in origin, and in destiny. The cosmos holds you gently, just as it holds Earth, and every moment of your life unfolds within that vast, serene embrace as the motions of Earth continue, smooth and unbroken. May they remind you that you are carried too. No rush, no pressure, no strain. Only the quiet journey of a planet moving through the galaxy with perfect calm, inviting you to rest in that same stillness inside yourself.